Now let's have another set of examples, which are applications of linear equations. The sum of four consecutive odd numbers is 56. Find the greatest of the four numbers. So let's say my first number, just an example, let's say my first number is 3, then the other three odd numbers must be 3, 5, 7, 9, since they are the consecutive odd numbers. Now, I am showing you this for you to see that there is a common difference between our odd numbers, and that is 2, correct? So we will be using this idea in order to represent our odd numbers. So let's say our first odd number will be represented by x. So the second, or next to it, must be x plus 2. And from the second, we will add another 2 to get the third. So x plus 2 will be added by another 2, and that is simply x plus 4. And for the fourth one, we add another 2 to our previous term, which is x plus 4. So we add 2, and that gives us x plus 6. Now we have 4 expressions representing our 4 consecutive odd numbers. And based on the problem, to create our working equation, the sum of these 4 odd numbers is 56. So we will equate the sum of x and x plus 2 and x plus 4 and x plus 6 to 56, or to find the value of our variable. And simplifying this, we have x plus x plus x plus x, so that's 4x plus 2 plus 4 plus 6, that is 12, equals 56. Now let's subtract it by 12 or add a negative 12. So we can cancel this, and we'll have 4x equals 44. And lastly, divide both sides by 4. So we can cancel the 4 here. And this gives us x is equal to 11. So if x is 11, we want to find the greatest among the 4 numbers. So this is 11. This is 11. This must be 13. This must be 15. And the last one is, or the greatest one is 17. So our final answer is 17. Okay? Here's another age problem. A man is 6 times as old as his daughter. 20 years later, the man will be twice as old as his daughter. Find the age of the man when his daughter was born. Okay, let's find some clues to identify what period of their ages are involved in the problem, or are given in the problem. The first one is actually in our first sentence. A man is 6 times as old as his daughter. So it's in present tense, which means we are talking about their present ages here. Then the next one is, in the second sentence, 20 years later. So it's actually the future age because of the term later, or the following 20 years. Okay, so after 20 years, the man will be twice as old as his daughter. Now, how do we represent their ages? Let's use D for the daughter and M for the man, or the father. Now, in the present age, the man's age was described through his daughters. So we represent this as x, so we can represent now the man's age, which is 6 times as the daughter's age. So that will be 6x. Using their present ages, we can now express their future ages by simply adding 20, because it says here 20 years later. So we add 20 to the daughter's age. We also add 20 to the man's age. So this represents their future ages. Now, for our working equation, okay, we will be using again the second sentence because there's a comparison used here. Like, 20 years later, the man will be twice as old as his daughter. So after 20 years, the man's age, which is 6x plus 20, will be, or is equal to, twice the age of his daughter. So that is 2 times x plus 20. Okay? And we simplify this. 6x plus 20. Distribute. You have 2x plus 40. Now let's subtract 20 on both sides. And we'll have 6x equals 2x plus 20. 40 minus 20 is 20. Okay, and then next is we'll have to subtract 2x on both sides, or add a negative 2x so we can cancel the variable in the right side, and we'll just have 4x equals 20. And lastly, divide both sides by 4. Okay, x will be equal to 5. And what is x? Based on our representation, it represents the daughter's present age. That if the daughter's present age is 5, then the father's age is 6 times 5 or 30. But the question is, we need to find the age of the man when the daughter was born. So technically, the age of the daughter is still 0. So if the present age is 5, so we subtract 5 from 30. Okay, so the answer will be 30 minus the current age of the daughter, which is 5, to mean that when the daughter was born, the father was 25 years old. And this will be our final answer. For our last example, we have a money problem. John has 12 more 10-cent coins than 20-cent coins. The total value of all his coins is 5.40 pesos or 5 pesos and 40 centavos. Find the total number of coins he has. Okay, to start with, of course, we need to represent the number of our 10-cent coins and our 20-cent coins. So let's say this is the number of the 10-cent coins and the number of 20-cent coins. Now, as to where we will start, it depends on how they were described in our problem. And according to our first sentence, John has 12 more 10-cent coins than 20-cent coins. So, what the sentence is trying to say is that our 10-cent coins was described based on the number of 20-cent coins. So, that gives us the idea that our 20-cent coins will be let as our variable so that we can represent now our 10-cent coins as x plus 12. Since it says here 12, it has 12 more 10-cent coins than or compared to the 20-cent coins. Okay? And now that you have the representation for the number of the cents, we can now jump to our second sentence, which will give us an idea on what will be the look of our equation. Because it is referring to the total value of the coins. And if you want to get the total value or the actual value of the coins, we multiply. If we multiply the number of our 10 cents, which is x plus 12, multiply it to 0.1, which is the value of our coins, or which is the value of each coin, plus the number of 20-cent coin, multiply it to the value of each coin, each 20 coin, which is 0.2. And the sum must be equal to 5 pesos and 40 centavos, or simply 5.4. Now let's multiply 0.1 to each of the term. We'll have 0.1x plus 1.2 and then plus 0.2x equals 5.4. Let's add this to. We'll have 0.3x plus 1.2 here equals 5.4. And let's subtract 1.2 on both sides, or add negative 1.2. That's the same. We'll have 0.3x. Okay, 0.3x equals 4.2. Okay, and dividing both sides by 0.3, 0.3, the answer will be x will be equal to 14, which means the number of our 20-cent coins is 14, and this is 14 plus 12 equals 26. So he has a total of 26 10-cent coins and 14 20-cent coins. Alright, that's it. And for your task, kindly answer this. So this is all about a fraction referring to the numerator and denominator. Good luck, and please make sure to comment down your answer if you have found it in our comment section.